today we're working on 9.5, which is factoring trinomials of the type x squared plus bx plus c. We'll be able to factor a couple different types of trinomials when we are done with this. Okay, so the first thing we are looking at is x squared plus 8x plus 15. And you will notice this follows the x squared plus bx plus c. In the next lesson, we're going to be looking at when we actually have a different coefficient other than 1, but right now all my coefficients are going to be 1 here. And what I really want you to notice of what's happening here is that we have two addition signs. Okay, so first thing we do here, and we are trying to factor this trinomial, tri means 3, so we have a 3 term, is take a look at my c value, this last value here, my 15, and identify the factors of 15. So 1 times 15 equals 15, and 3 times 5 equals 15. They're my only two. To make this piece, finding the factors easier, what we've done in the past is wrote them all out. 1 times 15 is 15. 2 times nothing. 3 times 5 would work. 4 times nothing will give me 15. And then I have my next term already, 5, so I have found all the factors, 1 and 15, 3 and 5. Now the second part of this is being able to identify the pair that add up to my b value. So 1 plus 15 gives me 16, and 3 plus 5 gives me 8. So I know I want to be using these factors. And this is kind of that trick at figuring out what we're going to put inside of our parentheses. So when I ask to factor this, what I'm going to do is create two sets of parentheses and put my x's, because my leading coefficient isn't 1, I'm going to put both 1's here, and I'm using 3 and 5. Now because addition is used in both spots here, we can use plus 3 for both. Plus 3 and plus 5, so addition for both. So the trick here is when you're factoring this, is take your c, that last value, figure out all the factors, which we did right here, and then figure out which one add up to your b value, that second term. So let's check it. I have first x times x, x squared, outer, 5x, inner, 3x, last, 15. 5 plus 3 gives me 8, so this does check with what I originally started with. I have another equation here that I'm going to rechange for you. This is how I'm guessing you guys like to see it with your x's, but we can use c's, and that's what we will use throughout this problem. But understand that's saying the same thing, just a different variable. My leading coefficient is 1, and 9 and 20. So what is different about this equation than the last one that we factored is that we have a subtraction and then an addition sign. So how does that affect it? So since the middle term is negative, we need to find the negative factors of 20. So find the negative factors of 20. We have negative 1 times negative 20. Negative 2 times negative 10. Negative 3 times negative 7 and give me a 21, so 3 does not work. How about negative 4 and negative 5? Now, these are all my factors. So, as you can see here, negative 1 times negative 20, negative 2 times negative 10, negative 4 times negative 5. Now, I need to figure out which one of these add up to my b value, that negative 9 here, that second term. Negative 1 plus negative 20, negative 21. That don't work. Negative 2 plus negative 10, negative 12. That don't work. Negative 4 plus negative 5 does give me a negative 9. So I'm going to be using negative 4 and negative 5. So once again, when you're asked to factor, create your two sets of parentheses. We're going to have c's instead of my x's. and I'm going to use minus 4 minus 5. Now let's check it, see if this actually works. C times C, C squared, C, negative 5C, inner, negative 4C, and last is negative 20. Negative 4 plus negative 5, negative 9C, minus 20, and then C squared, which does check to what I originally started with. And also remember from your rules that we talked about yesterday that both here are this is different from the rules we talked about yesterday, is because we have different terms, so we do need to FOIL these out. Now we're looking at same setup. Your A here is 1, but now I have an addition and then a subtraction sign. So right away we're trying to find my factors of negative 48 that add up to a positive 13. So let's take a look. Negative 48, we have 1 and negative 48, so we could write these as negative 1, negative 48. And this is actually a positive 1 because that would give me a positive 48. I want a negative 48. We have, down here I'm going to do the other ones. This is going to get really, really close here. Negative 1 and a positive 48. So why do I have one of each? These are not the same because here 1's positive and negative, and then 48 is negative. Here my 1 is negative and a positive 48. And that's going to affect it. So we do have to list both. Now I have a positive 2. Let's go a negative 24. We're down here, let's go negative 2 and a positive 24. Now let's go 3 and positive 3, negative 16. Where let's go negative 3, positive 16. So these ones are a little more tedious when you have subtraction at the end because you have to check all of them. So I have all my factors. Trust me, 4, 5, 6, 7, 8, all the way to 16 does not work. Now, when I add these up, 1 plus negative 48 gives me a negative 47. Get a positive 47. Negative 22, 24 plus negative 2 gives me a 22. 3 plus negative 13 gives you a negative 16 gives you negative 13. Then this last one, ding, 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 3 plus negative 3 is going to give you a positive 13, which is what we are looking for. So we know we're going to use 16 and negative 3. I have two sets parentheses. I'm going to have an x and an x. I'm going to add 16 and I'm going to subtract 3. I use both of them. Now check this. We're going to get an x squared plus a negative 3x on my inner. We're going to get a positive 16x, and the last is going to be a negative 48. These simplify into a positive 13x plus negative 48 and an x squared out front, and that does check. Alright, let's take a look at this next example here, where I have a negative and a negative. What am I going to do? Well, we're going to find our factors of a negative 24 that add up to a negative 5. So let's list them out. Here we have 1 and negative 24. So if you like doing this, you're more than welcome. We have 1, negative 24. Positive 1 and a negative 24. Here I would have a negative 1 and then a positive 24. How about 2? Let's go a positive 2 with a negative 12. And then a negative 2 with a positive 12. And we can look at plus 3 minus a negative 8, or negative 3 and a positive 8. So notice as you're kind of going through these, they stopped, and it's because they're checking as they go instead of listing all of them out, which is actually probably a pretty good idea because it saves you some time. So let's start going back through. 1 plus negative 24 gives you negative 23. Doesn't work. Remember, we're trying to get a negative 5 here. 24 plus negative 1 doesn't work. 2 plus negative 12 doesn't work. 12 plus negative 2 doesn't work. Now let's try this. 3 plus negative 8 gives me a negative 5, which is what I'm looking for. So once again, create my two sets of parentheses. I'm using x and x because my leading coefficient is 1, which we'll get into a little more of that later. I'm using a plus 3 and a minus 8. Now let's check it. FOIL first. Outer. Inner. 3 times x. Last. Negative 8 plus 3 is going to give me a negative 5x minus 24 x squared out front. This does match what we started with, so this is the factors I'm looking for. So this is what I'm looking for, and that you've checked to make sure. Our last example today is looking when we have both a d and a g. So we don't have just one variable, now we have two. So what are we going to do? Still find the factors of g, or of my c, sorry. Find factors of this that add up to a positive 17. So you can see they've went through all this work. Pause the video here and you can take a look. If you're confused on how this works, try all these out. What they're going to get to here is this bottom one, that 20 and negative 3 work as a factor. So because the sum is 17, that's the pair. That's the order pair that we're looking for, is 20 and negative 3. What does that look like? Well, I have a d squared and a g squared at the end, so I know my d, and this is where it gets a little complex here. My d is going to be a leading coefficient of 1, because in order when I do my first to get d squared, it has to be just 1's out in front of these. Okay, so 1 times d, 1 times d. Now, the last part is g squared. So I know I have to have a g here to get a g squared. Now I need to put in my two terms, my two order pairs, 20 and negative 3, and figuring out where they belong. So I got a negative 3g plus 20g. So this part does get tricky, where you put these, and you're going to see that even more later on. And it's just trial and error and checking your work. Checking your work. Checking your work. Make sure you do it. So d times d is going to give me d squared. D outer, d times 20g is going to give me a positive 20 dg. Inner, negative 3 dg. Last, negative 3 times 20 gives me a negative 60 g squared. This is going to simplify to 17 gd minus 60 g squared plus d squared. This is a 1. So that does check. So because that checks, you know you found the factor for these. So that's all for today.